So this section is called substances. This is part 2. First was energies. The third section is called opportunities. Under substances, we will look at nitrogen, carbon, past, present, and future, and then sulfur. Obviously, we already talked about sulfur in terms of injecting it into the stratosphere, either as sulfur dioxide or as sulfuric acid. We start with nitrogen, and the thinking really is to see if the nitrogen cycle that has been perturbed so severely and so globally with all kinds of intended and unintended consequences, whether it can be thought of as a geoengineering as well, and whether it's just a mess or a well-intended geoengineering experiment that has created a mess, and how does that what does that imply for the future of the geoengineering that we are talking about. So here is a statement from Alfred Lotka that says there can be little doubt that from now on synthetic nitrogen compounds will continue to be drawn in increasing amounts from the atmosphere into the life cycle. Atmosphere is almost 80% nitrogen, so there's plenty of it. This extraordinary development is something much more than a fundamental new departure in industry. It represents nothing less than the ushering in of a new ethnological era in the history of human race, a new cosmic epoch. In the short span of a dozen years, geologically speaking, in an instant, man has initiated transformations literally comparable in magnitude with the cosmic processes. So the nitrogen cycle, as we know, there is various forms of nitrogen. The nitrogen, dinitrogen N2 that's in the atmosphere and in abundance gets into what are called fixed forms, or oxygenated or reduced, like ammonium and N2O, NOx, and so on. This happens naturally, as we will see, due to lightning and so on, and there is bacteria and microbes which can fix nitrogen in the soil, of course, and in the ocean, because many of the other photosynthesizing species have evolved to not be able to directly use nitrogen but rely on fixed nitrogen, and then there are cycles that go between fixed and dinitrogen. So here is the example. There are oxic nitrogen forms like NO2 minus, so ammonia gets oxidized into that. There is nitrite oxidation producing nitrate, and then again nitrite here, and into NO and N2O. You already heard of N2O as a very powerful greenhouse gas, almost 300 times the global warming potential of carbon dioxide. There are processes that are called denitrification, especially some bacteria and microbes that live in environments which don't have much oxygen. They can split nitrates and nitrites to produce oxygen and convert it into NO and N2O, and then eventually into N2, which through nitrogen fixation in the ocean and in the soil can go into ammonium. There are also organic nitrogen ammonification that happens, and there are what are called anemox. So reactions that happen without ammonium oxidation that happen in the absence of oxygen, so anaerobic ammonium oxidation. The biggest perturbation by humans to the nitrogen cycle, of course, came from the Haber-Bosch process in the early and second decade of 1900s. So 20th century, Haber and Bosch both won Nobel Prizes for their role in it, and obviously that has led to enormous increases in food production through fertilizer manufacturing by those processes that we look at. But it's also been used to build bombs, and maybe 150 million deaths can be attributed to bombs built with the same process. You can raise all kinds of questions about whether the food production and the consequences of the industrial agriculture and so on, and the population growth that it facilitated are a good thing or a bad thing. For example, the Malthusian disasters that were predicted to say that food production is always at its maximum and population tends to overrun it, and then there will be starvation and mass death and so on. Even in the 1960s and 70s, books like The Population Bomb by Paul Ulrich and his wife were written arguing that population was growing too fast and food production wouldn't keep up. But normal borelog, fertilizers, and green revolution came along, and countries like India, Mexico, Brazil, and so on did fine by growing more and more food in less and less land. So does that mean that this invention actually facilitated population growth, or did it just provide what we called before as a breathing room to increase food production as population was growing, so that now fertility rates are dropping, especially because of educating women, and population is potentially going to drop because many countries are already below replacement in terms of birth rates. So all kinds of heuristic arguments can be made in this context. So the other context is to just go back to the actual facts on what happened on the ground, and it's been asked whether nitrogen is the next carbon in terms of its impact on climate and the planet. So carbon and nitrogen are close to each other. As you know, we talk about C14, which is produced by cosmic rays bombarding nitrogen in the atmosphere, converting one of the protons into a neutron, which makes C6 plus 8. So 6 protons plus 8 neutrons, because N7, when it goes to 6 protons, it becomes carbon. So you get C14, which is radioactive and can be used for dating and so on and so forth, right? Quickly, increase in nitrogen fixation and CO2 emissions. 1961 level is set to 1 year, and going from 1900, you can see that nitrogen fertilizer production and CO2 emissions have kind of gone together, not directly related, but we will see that they are indirectly deeply related. NOx emissions have gone up because of fossil fuel burning, and we know that that has an impact on ozone hole as well, as we will see. And crop nitrogen fixation has gone up along with the fertilizer use, and this has created all kinds of complicated interactions at planetary scale, which essentially is like a geoengineering, even though the goal was not actually to do any geoengineering. So the cycle is heavily perturbed from all kinds of human activities, fertilizer application, runoff, and air pollution. So fertilizer runoff into groundwater, surface water, the introduction of nitrogen into the air as nitrite, and deposition, aerial depositions of nitrogen, wet and dry deposition. Then you have denitrification, producing nitrogen gas back, nitrification producing ammonium, waste and decomposition, landfills that we talked about, and biomass plants and animals, feedstock operations, and production of meat and so on, and nitrogen fixation by lightning still goes on. So anthropogenic cultivation of nitrogen fixing crops have grown up as well, because fertilizers, for example, degrade soils, and to make up for it we use nitrogen fixing crops as intercrops, sometimes like legumes and so on, which are good at fixing nitrogen into the soil, which improves soil health and so on. So we will come back and look at more human impacts on the nitrogen cycle and how that cascades into every other aspect, including energy demand and CO2 emissions. So nitrogen is now a global phenomenon due to human activities.